Welcome to Ask and Learn.
Alright guys, to solve this problem, we first need to use the given temperature, that is T1, which is 35 degrees centigrades, and the humidity 51 is equal to 30%, and the pressure P is equal to 90 kilopascal. To determine the vapor pressure, that is PV1, and from that the dry air pressure PA1, we have PV1 is equal to 51 multiplied by Pg1 is equal to zero point 0.3 multiplied by 5.6291, and the answer is 1.6887 kilopascal. Then we have PA1 is equal to P minus PV1 is equal to 90 into 1.6887 is equal to 88.311. Now we can calculate the absolute humidity, and from the enthalpy H1. So for the calculation we will also need the Hg1 value, that is 25 6 to 2564.6 kilojoules per kg, and we find the value of W1, that is 0.622 multiplied by PV1 is equal to P minus PV. So we have W1 P minus PV1. So we have W1 is equal to 0.622 multiplied by 1.6887 divided by 90 minus 1.6887, and that is equal to 0.012. So we know that H1 is equal to Cp into T1 plus W into Hg1. So we have 1.005 into 35 plus 0.012 multiplied by 2564.6, and that is equal to 65.95 kilojoules per kg. So next we can calculate the specific volume V1, and from that the mass flow rate using the given volume flow rate, that is V1 is equal to 15 cubic meters per minute, and we have V1 is equal to RA into T1 over PA1, that is equal to 0.287 multiplied by 308 divided by 88.311, and that is equal to 1.01. Then we have M1 is equal to capital V1 divided by small v1. So it's 15 over 1.001 is equal to 14.99. So moving further, guys, we will also need the same parameters for the second flow. First, we need to use the given temperature, that is T2, which is equal to 12 degrees centigrades, and relative humidity, that is phi2, which is equal to 90%, and the pressure, that is P is equal to 90 kilopascal. To determine vapor pressure PV2, and from that the dry air pressure PA2. So PV2 is equal to phi2 multiplied by Pg2, that is equal to zero point 0.9 multiplied by 1.400 is equal to 1.260 kilopascal. And then we have PA2, that is equal to P minus Pg2. So it's 90 minus 1.2 uh, P minus PV2, not Pg2. It's PV2. It's 1.60260, that is equal to 88.74 kilopascal. Now we calculate the absolute humidity, that is W2, and from the enthalpy H2. For the calculation, we will also need the value of Hg2, that is equal to 2520 kilojoules per kg. 2520 kilojoules per kg. So guys, we've got the value of W2 is equal to 0.622 minus PV2 divided by P minus PV2, and that is equal to 0.622 multiplied by 1.260 divided by 90 minus 1.260 is equal to 0.00883. Then we've got the value of H2 is equal to Cp into T2 plus W into Hg2, that is equal to 1.005 multiplied by 12 plus 0.00883 multiplied by 2520, and that is equal to 34.31 kilojoules per kg. Next, we can calculate the specific volume B2, and from that the mass flow rate using the given volume flow rate, that is V2 is equal to 25 cubic meters per minute. We have V2 is equal to RA multiplied by T2 divided by PA2, that is equal to 0.287 multiplied by 285 divided by 88.74 is equal to 0.922. So we've got the formula M2 is equal to V2 divided by small v2 is equal to 25 divided by 0.922 is equal to 27.11 kg per minute. So now we can use the mixing ratio to calculate the absolute humidity, that is W3, and the enthalpy. So we have M1 over M2 is equal to W2 minus W3 divided by W3 minus W1, and that is 14.99 divided by 27.11 is equal to 0.00883 minus W3 divided by W3 minus 0.012. So the value of W3 is equal to 0.00996. So guys, moving further, we have M1 over M2, that is H2 minus H3 divided by H3 minus H1, and that is equal to 14.99 divided by 27.11 is equal to 34.31 minus H3 divided by H3 minus 61.95, and the answer is 44.15 kilojoules per kg. So we can now take the known equation for enthalpy H3 and approximate the enthalpy Hg3 to solve the equation for temperature T. So we have H3 is equal to Cp into T3 plus W3 into Hg3. So now we put the values here. 44.15 is equal to 1.005 multiplied by T3 plus 0.00996 multiplied by 2501.3 plus 1.82 into T3. So guys, after solving this, we get the value of T3 to be 18.8 degree. centigrades. So from the absolute humidity, we can calculate the vapor pressure, that is PV3. So W3 is equal to 0.622 multiplied by PV3 divided by P minus PV3. So that can be calculated as 0.00996 is equal to 0.622 multiplied by PV3 divided by 90 minus PV3. So we have the value for PV3 that is equal to 1.418 kilopascal. Then we can use that to calculate the needed relative humidity, that is phi 3, and dry air pressure, that is PA. So we have phi 3 is equal to PV3 divided by PG3 is equal to 1.418 divided by 2.17 is equal to 65.3%. Then we have PA3 is equal to P minus PV3 is equal to 90 minus 1.418 is equal to 88.582. So we can now take the pressure PA3 and use it to calculate the specific volume V3. So V3 is equal to RA into T3 divided by PA3. So it is 0.287 multiplied by 291.8 divided by 88.582 is equal to 0.945. So using the conservation of mass, we can calculate the mass flow rate, that is M3 is equal to M1 plus M2, that is equal to 14.99 plus 27.11 is equal to 44.1 kg per minute. And finally, we can calculate the volume flow rate, that is V3 is equal to M3 into V3 is equal to 44.1 multiplied by 0.945 is equal to 41.67 cubic meters per minute. So guys, these are the answers to this question. I hope you have easily understood all the formulas and the calculations. Thank you very much.